Awesome. Looks like we have a good amount of people here today. So thank you all again for coming. So today we have Mike from Cryptonomic, who will kind of talk to us about the Cryptonomic stack and go through Conseil.js and do a quick workshop with us. So he's gonna provide us some code along the way, so you can work along with him to see kind of how the code runs and everything. So if you have any questions, feel free to throw it either in the chat or in the Q&A box as usual. And as usual, this will be recorded on YouTube in case you have any questions afterwards or you want to revisit any of the topics. So thanks for coming, Mike. Feel free to take it away.
Thank you. One moment. Hi, guys. I'm Mike from Cryptonomic. I like to paste when I present. That's our wonderful logo. So today, we're going to talk about Tezos and how you can build dApps on it using the Cryptonomic stack. And one of the most exciting features to me about our dApp tools is actually the fact that you can do all this stuff trustlessly with the blockchain. Excellent. So we don't have a ton of time. These workshops usually take between 4 and 6 hours because they are supposed to be interactive, and we are going to be running code today. Hopefully, you won't have too many questions because the code actually works flawlessly. But if you do, I'll make myself available to address any of your concerns and problems. So yeah, we're a company committed to those hard to pronounce words. It's very exciting to be working in a space where spell check doesn't recognize some of the things you write on a regular basis in email. We are a blockchain agnostic company, but all of the public work that we've done recently has been centered around Tezos. Excellent. So we are a small core team based in Bushwick, in Brooklyn, New York City. It contributes a lot to our hipster cred. At the moment, though, I think last time I was at the office was 2.5 months ago, maybe 3. I lost count of the days. But yeah, it's an exciting time. The team has a broad collection of experiences. A bunch of us came from corporate finance, so we have decades of experience between us building large financial systems with a high level of complexity. We also have a requisite PhD. I'm not a PhD. My major contribution to the team is a snark, which is why I get to present. So we've been working on blockchains for several years. This slide is a little old. It's about a year old at this point. And every time I present it, I was like, yes, we have finally reached a point where instead of building for blockchains, we can build on blockchains. And I feel like every time I do this, it is true once again for some different collection of reasons. So yes, of course, we build a lot of tools for blockchains, for Tezos specifically, that help other developers build dApps and other applications that interact with blockchains. But at the same time, we also use the same stack, the libraries, the services that I'm going to show you later, to create our own products. So it's exciting to be able to build tools and then build on top of these tools to actually create a product. On the non-technical side, we also build communities. We host our own workshops and hackathons and meetups, although, of course, not anything recently. Right, so we've built a bunch of stuff. I like to think it's magical, so let's talk about some of it. This is our wallet, Galleon. You're looking at Galleon Preview, the current release. And it's a fully featured wallet specifically for Tezos. It has native support for like proper Tezos functionality. We follow the development of the Tezos blockchain very closely. As you might know, Tezos has a on-chain governance process, which every several months results in a protocol upgrade, which brings new features or changes the way existing features work. Galleon follows this process very closely. We're constantly up to date and support the latest features. The screen you're looking at specifically is a functionality we added recently, which allows you to sign arbitrary messages that you can share them with other people. And there's also a verify tab. This is just a screenshot, not interactive. So the verify tab allows you to confirm messages you receive from other people that they are indeed authentic. And the trustless aspect of that is there is no public key pre-sharing step. What happens is if I would like to communicate, let's say with Spencer, I can type in a message here, produce a signature. He already knows what my TZ1 account is. I will send him the message with the signature. He will plug it into the verify screen and confirm that it is indeed from me. But the way he does that, the application will go out to the blockchain and retrieve my public key from the chain. So I'm not communicating my public key to him, which potentially can be intercepted and modified. This is MiniNex. It's our block key explorer for Tezos. This is a dashboard we released recently, which talks about the summary state of the chain at any given moment. This is a screenshot, I think, from last night. It incidentally talks about the governance process on the right, and at the moment there are no proposals live. We also have Aranex. I like to present this view for hackathon-oriented decks because you can see here sort of the power of this reporting tool. So Aranex is not really a block explorer as much as it is a way to understand on-chain data in a way that makes sense to you. So we present all the objects on the Tezos chain, and we allow you to create custom reports. You can put together a report that has only a subset of fields of a particular item, like operations. In this case, I'm only looking at a small subset of the information available about an operation. I'm filtering it in a particular way. So these are all transactions with a destination starting with KT1, which means this is a contract invocation. And these are incidentally all of the ones that failed for one reason or another. You see status is not applied. So in this case, I have status failed and backtracked. And it produces the error. It shows you the error that failed, and it gives you the parameters with which this contract was invoked. So we built Aranex originally with the idea that this would be a financial reporting tool because blockchains are a new kind of finance, and finance needs reporting, rich reporting. So we have this, but it turned out that even for development purposes, when you're building new smart contracts, it is useful to learn from other people, and Aranex allows you to surface contract interactions very easily in a meaningful way. Finally, Nautilus Cloud, and this is something we're going to use today. This is our infrastructure service. This is based largely on the same infrastructure and code that we're on for ourselves. So we host a wallet, which means we host blockchain infrastructure. Not only do we have nodes, but as you see, because we have block explorers and reporting tools, we also have an indexer. Can say we're going to cover that. So Nautilus Cloud is a service that offers you a turnkey solution for both the indexer and the Tezos node, and you get access to both production and development. Don't bother copying these keys. I have refreshed them since the screenshot, but you can get new ones for free, and I'll explain how. So this is our sort of publicly facing product mix as it exists today. And all of this stuff is built using all of the libraries and services that we have. Specifically, I said that we have Kinsei, and Kinsei is a modular indexing solution. So it works like any blockchain indexer might. We monitor the chain for blocks, read them into our database, transform them into presentable fashion. Eventually, they end up on things like Aranex and MiniNex. And of course, Galleon uses Kinsei in order to be able to quickly show you all the transactions of a particular account. So we don't need to traverse the entire chain, but you guys know how indexes work. Kinsei.js does two things. One, it is clearly an interface to the Kinsei indexer, and we have a very rich JSON API for that. You can specify a query with the fields that you need, the filters that you want to apply. We have support for aggregations. We can do things like min, max, average, sum, etc. That's one. Also, Kinsei.js allows you to interact with Tezos nodes directly. And as I said earlier, I was excited about how our stack is trustless. So Consei.js has an integrated Michelson parser. Michelson is the smart contract language for Tezos. And we are able to take the contract that you write in Michelson and transform it all the way down into a message that can be submitted to the Tezos node, of course, signed by your private key locally, to the chain. And the entire transformation happens on your machine with code you can see yourself. We have a parser written using the Nearly library, and all of this code is in GitHub, and you'll get links for that later. This is a TypeScript library, and we publish it in a couple different ways. It's available on NPM. It's also packaged for web development, so we have a minified version. And we have ReasonML wrappers, if you'd like to use that. So this is what we're going to be using. Right, but I guess most of you are here to learn about how to write dApps, specifically for this hackathon. So let's talk about that. I think it's important to remember a few guiding principles, especially when working on blockchains. And one of them is to be careful. So you definitely want to read as much as possible about proper smart contract development and blockchain-oriented development in general. Definitely read all the docs. And for that matter, we have a bunch of documentation that I'll share with you. There's, of course, the Tezos white paper. There's the constantly updated Tezos node documentation being produced by core developers as well. So it's important to understand how to avoid problems. At the same time, if you've covered the documentation to some depth and you're still confused, the Tezos community is always eager to help people engage. So I'm around, my coworkers are around, we're available on a bunch of forums. You can always ask a question. Please ask an intelligent question, but you can always ask a question, and people will go to great lengths to help you. And for that matter, a bunch of the recent functionality, recent bug fixes, even in Consei.js that I've done, I did specifically at the request of users. Someone reached out to me, I guess about a month ago, saying that he was trying to deploy a Consei.js application in some way that was not working. And it wasn't working because the target environment did not support USB. And we have USB bindings because we support ledger hardware device signing, and it just wasn't working, and there was no way around it. So in the intervening month, I created a new version of Consei.js, which separates out the USB component so that it's pluggable instead. And now this gentleman can proceed with his work, and he indeed has. So that's always exciting. So we do want to hear from you. Do reach out. And I showed you earlier the report with the errors. So learn from other people's mistakes. I mean, I suppose collection of errors for a particular transaction is not very exciting, but you don't need to go very far to find catastrophic failures of smart contracts on blockchains. They happen once every week, and millions of dollars go missing. But you know, as scary as this might sound, it's important to be curious, right? And blockchains are intrinsically open source, right? They wouldn't work if the contract code was not public for public blockchains. So look around. We're going to cover some of the functionality in Consei.js today. You can take a random contract and understand how it works using Consei.js or using some of the other tools we're going to show you. And you can look at what other people are doing as well. So there are lots of ideas being thrown around on blockchains, but they generally fall into categories, and you can always learn something from someone who might be further along than you are, or who might be doing something slightly different, but still applicable to your own project. And of course, be creative, but like I said, don't start from scratch. Always look for some foundation to start from. So we might talk later about token contracts on Tezos. And there is a collection of standards being developed, again, by the community collectively. And people are thinking about and building token contracts. And you can look at that. And if you have a different token idea, you can still pick up concepts and even code. Finally, concentrate on your product. We made Nautilus Cloud available because running infrastructure is a consuming task. It is a 24/7 operation that requires constant monitoring and constant care. And it's not a statement on how unstable this code might be or how unstable the blockchain might be. It's just things happen and they need monitoring. So we have Nautilus Cloud, use it. Don't run your own nodes. And for the same reason, of course, we make Concede available as an indexer. Excellent. Oh, yes, one more point about being creative. So if you look at the discussions on the internet, detractors like to talk about how, oh, Tezos doesn't have this feature, Tezos doesn't have that feature, etc. And every now and then someone comes to me and says, well, I know you work on Tezos. How is it you're able to do anything? It doesn't have feature X. I was like, it's interesting that you should bring this up. I have never needed feature X. I can live fine without it and make interesting, productive things without some arbitrary feature that someone has on some other blockchain. So there's always more than one way to solve a problem. And it's not to say that your concerns may not be valid. It's just this chain is live now. It's been live for a while. It's being developed on, and you can do this. And if you can't, ask a question. Finally, I cannot understate how important it is to test your code. It's critical to test your code. And we're going to talk about SmartPy. And one reason we love SmartPy, which is not developed by us, by the way, it's developed by Smart Chain Arena. It has an integrated simulation engine, so you can actually see how your contract performs even before you deploy it to just the testnet. You can test it immediately to see how it responds to various inputs, and you can test edge conditions and all sorts of fun stuff like this. It's amazing. I'll give you an example. So I've been working on stuff for a while, obviously, and I'm not necessarily claiming to be the best person to write smart contracts, but I was toying around with the idea of a game at some point a couple months ago, and it turned out that I had a bug where if you were the loser, there was a condition which you could create which would allow you to take the entire winnings. And I figured this out by running SmartPy, just a bunch with various conditions. So you should definitely do that. Right, so let's actually do code. This is sort of interactive. I don't know how many questions I'll be able to realistically take from you guys. The idea is that you should have, well, I use Visual Studio Code, but whatever development environment you are happy with. We're going to be doing some TypeScript. All the code is already on GitHub. You will download it and run it. You may need to sign up for Nautilus Cloud if you haven't already to get some API keys. I will be available to address your questions. We have various chat rooms, Telegram, Discord, etc. I'll share links at the end. But yes, so let's do this. We'll be using Node.js, NPM TypeScript, pretty standard stuff. And we'll be using Concede.js, possibly Airnex. We kind of looked at that already. And of course, for connectivity, we have Nautilus Cloud. It looks like this. Please make an account, nautilus.cloud. Excellent. These are the materials. So let me switch to browser. Right, so here there's a bunch of stuff, links to Concede.js and everything else. There's, of course, documentation. Specifically, what I would like you to take a look at is the basic workflows gist. So the idea is the following. You need to have, excuse me, TypeScript. Well, pardon, you have to have NPM and Node. I prefer to be current LTS, so 12.16.3 is what I've been running this on. Node I usually install with NVM. NPM install, NPM start. So NPM install is going to pull a bunch of dependencies. The idea is that you will copy this index.ts and package.json into a folder on your computer. That might look like this. So this is actually that code. Right here, so I have my index.ts, I have my package.json, I already ran this. Right. And after that, oh yes, actually there's one more step, which is mentioned right in front of you, in front of me. You need a faucet account. So get one. Very simple process. Excellent. You're going to get something that looks like this. You can download the file. That file will look like that. And what happens then in the code, right here on this line, it'll pick up the file that you created, assuming it's named the same way that the download was, tz1 something.json, and it will kick off the entire process. Now, while you guys are running this, I can talk a little bit about what's actually going on. Let's see, what else do we have here? Yeah, so excellent. It'll initialize the account, which takes the account information and converts it into a key pair. So you get your public key and private key. The faucet account, and this is, I suppose, a minor point, the faucet account behaves like a fundraiser account, which is sort of like an ICO that happened on Tezos mainnet some years ago. If you create a new account, it is possible, of course, to create a new account, and it's not a faucet account, it's not a fundraiser account. That does not take all these parameters that you wouldn't have anyway. Then specifically for faucet accounts, there's an activation step. What this does is it claims the balance your account has associated with it with your key. So if you look at the file, it says amount. So balances on Tezos are expressed in mutez. So this is, if you divide this by 1 million, you will get the actual balance. So this account has 21,000 Tez. And the activation step basically says, yes, I'm raising my hand. I have this account, give me the balance. Then reveal. This is an important operation, and this operation has to happen anyway, regardless of whether or not you have a faucet account. So this is publishing your public key in a message signed with your private key, confirming that, yes, this is my public key. And I mentioned earlier the feature in Galleon that allows you to sign and verify messages. It uses this message from the chain to get your public key to confirm messages with. Now, as you see, this is going to be producing various bits of log as it runs along, and there's that. Cool. So then, simple, basic transactions, right? So you can, of course, send balances between accounts. I think I have some random addresses in here, which unfortunately may not be correct for CarthageNet. If they're not, simply go to Aranex. Select Carthage. And this is CarthageNet. This is the current test network, prevailing test network on Tezos. So if you need a baker, for example, a baker is validator on Tezos. I think every blockchain worth this, every blockchain worth its salt comes with their own custom lingo. So validators are bakers on Tezos. There's also a built-in time series mechanism. So we have block level, of course, but blocks are aggregated into cycles, and cycles are aggregated into periods. So yeah. In any case, you can read about those details if you wanted to later, but they're basically a way for you to group time periods for governance in Tezos. Cool. So Tezos has another interesting thing. So you probably know about the fact that it's a proof of stake chain, and as such, it has a delegation mechanism. The idea is that if you're a relatively small holder or you decide not to bake, you can delegate your balance in order to earn baking rewards that are generated every block. Again, the details are all over the internet. I can address specific questions if you have them, but the idea is that you definitely want your balance to be delegated unless you don't for some specific collection of reasons. And this operation will associate your balance with some particular baker that will then at a later date start sending you rewards. And there's a process for how this works on Tezos, but you will start getting rewards. for your balance. Incidentally, 21,000 Tez is enough to bake, but we're not going to do that today. Now, I suppose this is not entirely interesting, but historically, it was not possible to delegate your primary account, so to speak. So Tezos has two different kinds of accounts. It has implicit accounts and smart contract accounts. So originally, it was not possible to delegate implicit accounts. Implicit accounts had TZ1, TZ2, TZ3. Those 1, 2, 3 specify the curve being used to generate the key pair. So you can only delegate a smart contract, and this deploys a delegation smart contract, which all it does is allow you to delegate your balance. Then we have a couple of interactions with this contract: depositing funds, changing delegation, withdrawing funds. Because it's a smart contract, you actually have to have functionality for all these operations. What I mean by that is it is very easy to deploy a contract with a non-zero balance. However, if you do that, you will never be able to see this balance again, because unless the smart contract has a withdraw function in it. So something important to keep in mind. We'll cover that in a bit. Excellent. Yes, withdrawal. Okay, so these things start to get a little bit more interesting. So, as I said earlier, Michelson is the, here we have Michelson right down here, really simple contract. So Michelson is a smart contract language for Tezos. Most people probably aren't going to write it in Michelson. It's not the easiest thing in the world. And we're using SmartPy for that. Part of the reason why is that it's a nice, rich interface with lots of functionality. But before Michelson can be deployed to the blockchain, we need to convert it to this format called Michelin, and it's simply a JSON restatement of whatever you see here. So these contracts actually the same. Right, so Consay.js, this trustlessness that I was talking about earlier, is that it is able to take this and convert it into a message inside this function without interaction with the node. So normally, what you would do is you would talk to the forge operation endpoint on the Tezos node. You will send it, the contract then would send back the prepared hex that you would then sign and submit to the chain. But of course, this is not trustless in the sense that you could be connecting to a malicious node and things could go bad. Consay.js does this for you internally. Now, our parser is not perfect, but meaning that there's some subset of contracts that is not able to parse. But when that happens, you basically core dump. So, and because it runs in JavaScript, it just the process dies, and that's it. So nothing critical, nothing critically bad occurs. But yes, if you come across contracts that do not work, do let us know, and we'll update as much as we can. Cool. So this is going. So all of this stuff, by the way, it runs automatically down here. It just going step by step by step. So if you guys are running this on your own machines, this is what you should be seeing. You should be seeing all these log messages coming up. This entire thing takes, I think, like 15-ish minutes, 10, 15 minutes to run. So it could take a bit, because of course we're waiting for transaction confirmations on the chain. And this, by the way, is another nice feature of Consay.js. So we have this thing called await operation confirmation. And we give it the Consay server, which you would have gotten from Nautilus Cloud. The network, in this case, our network is CarthageNet because it's our test network. We have a group ID, which is the operation that we submitted. And then 5, in this case, it's the number of blocks I would like to wait before saying yes, we're done, or timeout, saying failed. And by the way, like the transaction could be still in mempool and just not processed. It's just I'm not going to wait more than 5 blocks. And network block time is essentially the number of seconds. So on the Carthage testnet, block time is 30 seconds. On mainnet, it's 60 seconds, give or take. Cool. So, right, invoking contracts. So again, we are able to encode all of this locally and trustlessly. Very exciting stuff. We're also able to estimate the cost of the operation. So obviously, different operations have different complexity on the contract, and there is a way to ask the node saying, hey, I would like to execute this operation. What would it cost? Like how much gas, how much storage? This function will give you a pair, gas and freight, which tells you how much it would cost, and then we're using those values later. Important thing to remember about gas on Tezos is it's not directly related to the fee that you pay for the transaction. So I have a fee here specified. I think it's something like half a Tez, something high. Testnet fees tend to be high. So just because bakers have high thresholds. The gas is, it's like a loop limit. Basically, you're saying how many operations you're willing to execute. Even though technically the relationship between fee and gas is not direct. However, with storage cost, the relationship is quite direct, but separate. So when you submit an operation to the Tezos chain, you provide a fee. We also provide this storage limit. That's the storage limit, is the name of the actual parameter. Storage limit says that you're willing to pay up to X to store some stuff on the blockchain. And this cost is not included in the fee. It will come out of your account as this operation is being persisted to the chain separately. So if I set the fee, for example, to 1 Tez, and I set storage limit to 1,000, what I'm actually saying is that I'm willing to pay up to 2 Tez to execute this operation, because 1 Tez is the fee, and that's going to be gone when the transaction is applied. And then the 1,000 storage limit is basically, it's 1 Tez. So it's 1/1000 is the unit. It's 1 Tez that I'm willing to pay up to that much. And if the operation I'm executing only takes half a Tez, then my total cost will be 1.5. But if it takes the whole 1 Tez, then there'll be 2 Tez. So it's up to. Excellent. And it's invoking contracts for you in a nutshell. This is a really simple contract. All it does is it stores the string on the chain, nothing else. And it just changes it. So we also have a function, Tezos node reader, to interrogate the storage of a contract. So it's all very nice and wrapped for you. One thing about ConsenJS, conceptually, it's written in a kind of a C-like style where there's not a lot of conventions like from React, for example. If you see a function, it has documentation. So like this function has documentation on it. And it's very easy to understand how it works, I would hope. And of course, we have code samples and so on available too. Cool, so these are the functions that are gonna run automatically. I don't know if I included these two. So these two are interesting. If you do indeed run parse contract, so what does this do? When you're just starting out working with Tezos, understanding how to call smart contracts is not obvious, I guess. The syntax is a little bit complex and weird, and we have a function which will download the smart contract code, parse it using that same parser I mentioned earlier, and present to you a list of functions this contract contains, along with a template in Michelson on how to call this contract. And all you would have to do at that point is substitute the templated out values for real values, and you're done. And then you can just call the contract like the same way that we're doing it here. Well, actually, yes. Yeah, so the same way we're doing it here. You can do this for your own custom contract, even though ConsenJS does not have explicit understanding of what your contract does. Finally, I mentioned something a minute ago about operations in the mempool. So under certain circumstances, you will submit an operation to a blockchain and it's not going to proceed. It will be a valid operation, but it's not going to be executed. So when that happens, we recently added a feature to allow you to download all of the mempool operations, and then you can estimate how long they're going to be sitting in there. Why is this important? So on Tezos, if you have a pending operation, you could not submit a new one. This is a security feature in some sense, but you would have to wait. And you wait 64 blocks. There's a technical reason why it's 64. It's related to the way the chain maintains the main trunk, if you will. Yeah, so estimate branch timeout will basically tell you, this operation will fall off the mempool in, let's say, 60 blocks or 20 blocks or whatever it may be. So this is like a lightning run through what Tensei.js can do for you. So let's see, we did all this stuff. We didn't do this stuff, but you can take a look at Ironex. There are blocks, operations accounts, bakers, governances, the voting summary. There's more stuff, account history, baking rights, and so on. There's a bunch of stuff here. You can look at maps, perhaps out of scope for this talk today. We did all this stuff. We moved we moved value, we delegated, we created a delegated account. Yes, let's talk about contract patterns. That's great. So, permanent deployment. Blockchains are an interesting platform where you can't really upgrade software, which is great in some sense, because once it's deployed, you always know that it will perform exactly the same operation it always has. The cryptographic guarantees maintaining this. Now, it's important to think about this because, again, you can't actually update your software. So I had a slide earlier about testing. Test. Privileged access. So Tezos is a permissionless chain. Anyone can join, anyone can execute an operation. If you are not checking permissions yourself, no one else is doing it for you either. And privileged access specifically, it's worth considering that you could have privileged users in different roles. So you could have an administrator that can do anything, let's say to a token balance, or you could have a different role that can issue tokens but not burn them, and so on. So think about privileged access in terms of what kind of different people might need privileged access and layer that so that not all of you administrators have complete power over your contract. So for example, if you deploy some sort of a contract which receives balances, you might want to have a function to set a delegate so that this contract itself is going to be earning delegation rewards. You would have, of course, add this function, but my point is that you would want to make it a privileged function so that not everyone can arbitrarily execute this code. What else? Unspendable funds. So this, I guess, is still newish in Tezos. The original deployment of the platform allowed the originator of the account, the deployer of the contract, to perform operations on this contract, any operation, which means that you can effectively impersonate the contract and send the balance to yourself. It is no longer possible. So unless your contract has a withdraw balance function, you get nothing. Related to this, of course, is that if your contract needs to spend money, like you have to have a function for this to perform this operation. Related to that, you can deploy a contract on behalf of someone, right? So we're talking about privileged access. So if I'm a developer, I can deploy a contract on behalf of Spencer, my client, and then hand him over the control of this contract by changing the admin account in the contract. So these are important patterns to think about. Right, so whitelisting, similar to privileged access, you may want to limit in general, even the number of, let's say, basic operations that can be, or who they can be performed by on the chain, because right now anyone can call a contract. So the contract that we deployed in part of this workshop stores a string, but like literally anyone on the chain can call this contract with a new string and the state changes immediately. So something to keep in mind. Finally, state rescue. So I said earlier that there is this delegation contract that was created in Tezos a few months ago to allow contracts to delegate explicitly. And I said that all it does is delegate. That's not actually true. What it does is it executes a lambda expression. And I can't specifically speak to the reasons why because I'm not part of the team that built it, but that kind of a function is great and dangerous at the same time because it's great because if you by accident screw something up, you can now execute completely arbitrary code, guaranteed to be yours because you were an admin of the contract, to change the state. Now, this is good, but it's bad because it potentially creates a lack of trust. So if I'm interacting with a contract that has a function that allows the admin to do completely arbitrary things, I am now concerned that they might do something nefarious because there are no guarantees on the chain to prevent them from doing that. So another thing to keep in mind. Considerations, what else? So input validation. This was an interesting problem. I was looking at a contract we were writing recently, and it had a bunch of validation for inputs. And I was thinking, why? If we don't validate input, the transaction will simply fail. And if you call the transaction incorrectly, you lose the fee and, you know, whatever, the chain moves on. The transaction failed, it was never recorded. I can instead validate the input and present a useful error saying, hey, this parameter should be something else. But what's going to happen is that valid operations will then cost more money. So people who are calling the contract correctly will still pay for executing this validation, which is weird. Storage. Storage is quite expensive. However, you don't necessarily need to store a lot in the contract itself, because keep in mind, it's a blockchain, which means there's a record of all operations that occurred. So all the state transitions will be recorded on chain, and you could use an indexer like Consafe, for example, to get the list of invocations in chronological order and extract the parameters. And that is a type of storage as well. And it's, of course, available from the blockchain itself. You can go specifically to the block where the transaction was executed, and that operation will be in there. So you don't specifically need to store everything in the contract and pay for it. Fractions. This was actually a SmartPy question recently. How do you do floats? You don't do floats. You don't do floats because floating point numbers cannot be deterministically reproduced on different platforms. So Tezos, for example, mitigates that issue by saying, well, 1 unit of Tez on the platform is 1 microtez, 1/1,000,000th of a Tez. So you get fractions implicitly. So if you want to express 1 whole Tez, it's actually 1,000,000. So you get fractions that way. External state. You may have seen the news. Smart Chain Arena and Cryptonomic are working on Chainlink integration with Tezos. Very exciting stuff. We're still working on this. Now, currently, if you needed some external information, especially, let's say, 2 or more pieces of external information in order to perform an operation in the contract, there's not an easy way to get it. And if you do get it from a different kind of oracle, for example, a non-trustless oracle, like there's some trusted party publishing, I don't know what kind of prices on an oracle, your smart contract calls that smart contract to get back a value, then your smart contract calls another smart contract to get another value. And then based on these 2, it performs an operation. Now, this is potentially problematic because you're executing 3 transactions now, and the state externally might have changed by the time you get to do yours. An important thing to keep in mind. Now, lastly, I do want to talk about these things. Blockchains are interesting, and big reason why is this. You cannot change the contract once it's deployed. You do not, well, you should not have arbitrary execution, which is this rescue function I mentioned earlier. And finally, Lambda storage. So Tezos allows you to store a function in the contract storage and execute that function from an entry point. So what it means is that if I'm a contract user and I reviewed your contract, which is, of course, what most people aren't going to do this, right? So I review the contract and I am satisfied that this contract is, let's say, safe to use for whatever my criteria are. And then I execute it. All this upgradability and arbitrary code execution and Lambda storage, they break these guarantees because the contract may have changed between me auditing it and me executing it. There could have been an operation saying, well, actually, we're going to switch this function to do something else. So upgradability specifically is actually implemented using the last part. What people do is entry points reference a piece of storage, and they say, well, when I'm called, just call that code over there. And then there's a separate function called upgrade. And the upgrade says, well, I'm going to change the function stored in the key, whatever, to something else. And then all of a sudden, the contract that you execute does something entirely different. So I think these are bad practices. Other people may disagree, but I think the whole point is that we need to have trustless, secure execution. Cool. So deploy contracts, we did. Invoke contracts, we did. Interaction patterns, worth covering really quickly. Ping. So there are different kinds of invocations, right? You can call a contract with no parameters, no balance. You can just say, hey, I'm Mike. And that's going to be recorded on the chain. So for example, if you wanted to have a poll of some sort where you had a really simple way to count votes, you could deploy 3 contracts for 3 different options in your poll and a blank invocation to any one of them using, let's say, you can then create a chart saying, this contract received this many votes, that contract received that many pings, and that's your vote tally. Invoke, of course, it would be with parameters. You're calling a function that takes parameters, does some stuff. Again, of course, these parameters will be recorded on the chain, so you can reference them later. But you do not provide a balance to this contract because you don't necessarily need to fund the contract, which is the next one. So the next thing, you're invoking a contract, but you're also giving it a balance of Tez for some reason that maybe you're buying tokens or you're paying for services, who knows? But the point is that you can invoke contracts with a 0 balance, and that's a perfectly valid use case. Lastly, chain. What that does is it allows you to invoke a contract from another contract. Cool stuff. So you can chain multiple operations into one, and it allows you to simplify your single contract. You break it up into multiple pieces, and this is great. Compose contracts. So this stuff, we'll go back to the web browser. As I said earlier, we have loads of documentation. And this is actually linked from the from here at the bottom. So we have a syllabus for developing smart contracts with SmartPy. You should definitely check it out. You should actually see what SmartPy looks like. Make sure you wait for that to load completely. Here's some contract. Incidentally, something I wrote a while ago. What do you know? Right, so this was like a not trustless Oracle. Yeah, I can post it somewhere if you guys like. Right, anyway, that's a contract. You hit the play button. It does a bunch of stuff. Apparently I have a bug in there somewhere. But take a look. It is running tests as we go along. So that's really, really useful. Okay, so that's our stuff. We're most active on Riot. We are known to be on Reddit and various other places. Telegram, we have a user support group, but Telegram is a cesspool of scammers, for lack of a better word, so be careful out there. Yeah, so, thanks for having me. Although we have 7 minutes. I want to talk about something else. Security. Hackathons are a common thing in blockchain space. They happen a lot. I've participated in some, judged others. Common thread, well, there are multiple, but one is people take security for granted. They assume that they will just build an application that does something interesting and they will deal with security implications of it later. But frequently, this is not easy or obvious or quick. So when you're building your dApp, think about how the user will interact with it securely. Think about how you will deploy it securely. Think about how you will administer it securely. And these are very important things. Basically, don't make your judges grade on a curve. Like, judges probably will assume that security is just something that will be handled later. I'm not one of them. I can't speak to their state of mind, but this is frequently the case. And it's possible in some cases that your idea is going to be completely undone by unrealistic security expectations. So I would like to show you a piece of code that we published as code, but not yet as an application, which is moving in the direction of secure dApps for Tezos. Specifically, it's login with Galleon. And you've seen these login with Google, login with Facebook buttons all over the web, of course. So we are providing a decentralized federated login. I don't even want to call it service because it's not a service. We're not running it. It is simply a feature of the Galleon wallet. And here's how it works. This is what it looks like actually when you load it in Galleon, and we're going to do that in 1 second. So we have this DApp authentication request header. Most awesome DApp is the name of my DApp. It has a description, dappy dappy. And disorder, disorder, victory are 3 words from the BIP39 dictionary, just 3 random words. And when you hit the authenticate button, what happens is it signs these words with a private key associated with an account and sends them back to the web service callback, which on the back end confirms the signature using that same workflow we discussed earlier with sign verify, and then says, yes, this person, whoever they are, has control of this private key. So let's actually, so the code is available, right? I will show you the code, but the code is up on my GitHub repo. I think I have one outstanding commit. Yes, I will push a commit shortly. But here's the code. It's a bunch of JavaScript. You can, of course, implement this in whatever your favorite language might be. And it will interact with the blockchain to get your public key, well, the public key of the account you're verifying, and confirm the message using cryptographic signatures. So we can actually run this. I already have Galleon open. Cool. I have this here. Okay. This is my address. This is incidentally the, excuse me, mainnet account that I'm using for support. So when you guys accidentally run out of balance to withdraw from your delegation account, this is where I send it to you from. Cool, so here we go. This is just like a really dumb, ugly sample. Here's some 3 words, randomly generated, close fiber real. Then you hit request, and you get this pop-up. So what this does is Galleon registers a custom URL scheme in your OS and says if you call it with Galleon : / some other stuff, you get this. So this is exactly like the screenshot we saw. I'm going to hit authenticate, signature sent, and internally it calls back to the service, and here you go, validated. So now the web service knows that my session, this current ephemeral session, actually does have control over this account. Now, this is just an example of what's possible. You could build DApp interfaces into Galleon. It's quite modular, the code base we're working with right now, and you could have a, let's take a look at the StakeIt token, for example. This is a completely custom UI that exists in the StakeIt directory inside Galleon, and it renders their contract in a specific way. So this is possible, and it's secure because my private key never touches the browser. I never copy and paste out of Galleon. All the signing happens here, and for that matter, this functionality is compatible with Ledger devices. So this is a file wallet, so it's soft signing. But if I had a Ledger connected, it would also be able to do all the same stuff inside these operations. So it is possible for you to write an application with a UI in Galleon, for example, that will use this secure environment and not the browser for the user. So these are the kinds of things that you should be thinking about, I would hope, when you're building your applications. So I think I'm, wow, 1 minute off of my timer. So I have some time if you guys have a lot of questions, but let me stop the screen share.
Awesome. If anyone has any questions, now's the time to toss it in the chat or the Q&A. No questions?
Excellent. Spectacular. Thank you very much for coming. I'm assuming the replay is going to be available. You'll be able to get all the links out and find us. I'm on Twitter. I can't spell my name. So see you on the blockchain.
Awesome. Yeah, thanks. Thank you for your time, Mike. So yeah, if any of you have any questions, toss the questions in all the channels Mike has mentioned or in the Discord. And yeah, this will be on YouTube shortly after today. So thank you all for your time and have a great weekend, everyone. Okay. Bye.
Bye-bye.